On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to talk about horizontal asymptotes of rational functions. This is going to be a shortcut. We can do these problems very fast as long as we follow 3 rules. These are the 3 rules. Feel free to pause the video and read over these, but I'm going to talk you through all 3 of them in these examples, and then we're also going to manipulate these functions over in Desmos to see how we can quickly determine a horizontal asymptote. When you're trying to find a horizontal asymptote of a rational function, you're really talking about the behavior of the function as x gets really big or as x gets really small. Hence the idea of a limit. The limit as x approaches infinity or the limit as x approaches negative infinity can lead to us determining horizontal asymptotes. So what I want you to notice here, we got an answer of 2 in a previous video when we talked about the graphical approach of looking at limits at infinity. Go back and check that video out and you can see how I did all of these already. But if you have watched that, notice that we're equal to 2. Let's look at h of x and notice the degrees. The degree of the top is 2, the degree of the bottom is 2. These degrees match up. What we want to do if the degrees match up is take the leading coefficient of each of those pieces, 4 and 2, and we want to divide them. 4 divided by 2 is 2, hence that 2 there. Now I could change this to a 3 and a 3, and if I left that 4 and that 2 alone, we would still have the same horizontal asymptote. With that said, let me show that to you. So here's the original h of x. We have degrees of 2 at the top and the bottom, but really what we're talking about are these leading coefficients. If the degrees match up, use the ratio of the leading coefficients to determine the horizontal asymptote. And if we notice here, 4 divided by 2 gives us 2. And we saw this in the previous video, but as you can see, as x gets big, this y value is going to get closer and closer and closer to 2, as you can see out here. Let's change these degrees to 3s. And notice the graph definitely looks different. However, as x gets really big, or as x gets really small, notice our y values are still approaching 2. That's our horizontal asymptote. Now, if I come in here and change this 4 to a 6, 6 divided by 2 gives us 3. Notice our horizontal asymptotes are now approaching 3, or our y values are approaching 3. Let's change this to a 9. We still have matching degrees. Take the ratio of the leading coefficients. 9 divided by 2 is 4.5. So as x gets really big, our y value is going to approach 4.5, as you can see right there. And as we move over this way, you'll notice that as x gets bigger, the y value is getting closer and closer to 4.5. Also, if we let x get really small, over here in the negative numbers, look at the y value there. It's getting close to 4.5. That's a great shortcut to know as long as your degrees match up. But back to this example, h of x, if we want to find the horizontal asymptote would be y equals 2. It would be a dotted line that would go across that function. Though the dotted line is not seen and is technically not part of the graph, remember just a moment ago we said 9 divided by 2 was 4.5. So this horizontal asymptote would be y equals 4.5. And we do have this red line up here, and notice the curve as x gets really big or as x gets really small, it starts to hug this red line. Now technically that red line is not there, but it's there for demonstration purposes for you to see that our horizontal asymptote is y equals 4.5. Now notice for question number 2, j of x, we got 0 for both of these. That is going to be our horizontal asymptote, y equals 0. And what I want you to notice now is the following. The degree of the top is smaller than the degree of the bottom. If the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is y equals 0. But notice this right here. We want to watch out for other things getting added or subtracted to the entire rational expression. Let me show that to you. Let's get down to number 4. Notice the degree of the top is 1, the degree of the bottom is 2. So that same rule is getting applied because the degree of the top is smaller than the degree of the bottom. But notice our limits over here were 3. Well, that's because we were adding this constant on. Let's explore these two options. So our horizontal asymptote here is going to be y equals 3. Let's explore j of x and s of x a little bit more, then we'll come back and talk about t of x over in Desmos. So here's our j of x, where the degree of the top is smaller than the degree of the bottom, and we said our horizontal asymptote would be y equals 0. That blue line, notice the green curve as x gets big and as x gets small, it starts to hug this blue line. That is our horizontal asymptote. Now looking at s of x, the degree of the top is smaller than the degree of the bottom. That's going to be 0, but think about 0 plus 3. Technically we get 3. That is our horizontal asymptote there, y equals 3. Notice that green line, as x gets big, this purple curve actually passes through it, and I did mention that in an earlier video. We can pass through a horizontal asymptote. We can never pass through a vertical asymptote. But notice as x gets big, our y value is getting really close to 3, both as x approaches positive infinity and as x approaches negative infinity. The y value on this curve gets close to 3. What happens if we change this to minus 2? This remained the same at 0 because the degree of the top is smaller than the degree of the bottom. Now minus 2, our horizontal asymptote is going to be negative 2. Notice when I type that in, the purple curve is now hugging negative 2, or a y value of negative 2 as x gets big, as you can see there. And as x gets small, notice the y value is still hugging somewhere close to negative 2. So that's what I mean about being careful if you're adding or subtracting something onto that rational function. So take note of that part of the rule. Now, rule number 1 was what we discussed back at the beginning, where we had the same degree at the top and the bottom, and I mentioned to use the ratios of the leading coefficients. Sometimes we don't have a horizontal asymptote though. That occurs when the degree of the numerator is bigger than the degree of the bottom. Let's look at an example. So looking here at t of x, notice we didn't get a number. We got like positive infinity and negative infinity. We don't have a horizontal asymptote because the curve is not going to flatten out. And that's going to always be the case in a rational function if the degree up here is bigger than the degree down here. So here's that t of x function again that we did see in earlier videos as well, but notice we don't have a flatten out. This curve shoots off as x gets big, the y value is shooting off to positive infinity. And as x gets really small, the y value shoots down to negative infinity. That is because the degree of the top is bigger than the degree of the bottom. If I change this to a 6, same thing is going to happen because this degree is bigger than this degree. Let's change this to a 21. Now the degree of the top is smaller than the degree of the bottom. This is where rule number 2 comes into play. Notice we do have a horizontal asymptote that's pretty much 0. Now technically it's not truly equal to 0, but it's really, really, really small. You could take 6.26 and plug it into this function. You would get something that's really close to 0, but not exactly 0. It's just that Desmos here, the rounding here is so close to 0 that they just show 0 on the screen. But I do want you to see that the horizontal asymptote in this case would be y equals 0. Let's change the top to 21. Now notice we have the same degrees. Use the leading coefficients, 1 over 1. That's why our horizontal asymptote is going to be 1 in this case. These 1 values that you see here are not exactly 1, it's just that Desmos is rounding. If I change this top one to 12 and the bottom one to 3, our degrees match up. Use the ratio of the leading coefficients, 12 divided by 3, now our horizontal asymptote is up here at 4. And again, the same rules with rounding in Desmos. If you plug in 5.35 into this function, you'll get something really, 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 really close to 4. And that's what Desmos is doing here, is rounding. All these values here are rounded, but I do want you to see that our horizontal asymptote in this case would be 4. And there you have it, the 3 shortcuts to quickly determine horizontal asymptotes. It's all about thinking about a limit as x approaches infinity or negative infinity. We're trying to determine what is the y value doing. Does it start to flatten out? And if it does flatten out, that's where you have horizontal asymptotes based on these rules. But sometimes it doesn't. Sometimes the graph will not flatten out and it may shoot off to positive or negative infinity. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.